Hi, welcome back to the Game Dev Engineer Super Duper Study Sheet. Today we're talking about binary and hexadecimal numbers. Let's do it. So this is a place where cracking the coding interview is just not going to help you. There's a lot of stuff here that you got to know that's kind of different, I guess I would say. It's not related to object-oriented nonsense. So the first thing is you need to know your powers of 2. They're pretty much always going to ask what's 2 to the power of 8. I've been asked that on almost every interview. And what is it? 256. And the way that I remember that is I just memorized 2 to the 6 is 64. For some reason, the alliteration of the 6's is something that I can easily memorize as a mnemonic. And then I say, okay, 2 to the 6 is 64, 128, 256. So 2 to the power of 8 is 256. And what does that represent? Well, there's 8 bits in a integer, so a bit can take on a 0 or 1. So 256 represents the number of permutations that you could have within that. Okay, wonderful. So then there's also quick reference here is for hexadecimal. And then the other thing you want to know is that when you're dealing with hexes, you're going to start dealing with multiple digits, right? And so the A is the 10, the C is the 12, the D is the 13. You just should have an intuitive understanding of that mapping and hopefully have it memorized. F15 or D13. Okay, so now let's talk about 2's complement. This is another way that we get to work with numbers, really common. So something that you do need to memorize. It's a 3-step process, though. It's not that complicated. So we're going to talk about binary, which has a little bit of a trick, but then we're going to talk about the bulletproof way that's always going to work, and we're going to use it on hex. So the first step is, the question is going to be something like this. They're going to say, hey, Matthew, or, hey, state your name here. What is -5 in binary? And so the first step is just to write the number in binary. Okay, just take the absolute value of that. So 5 in binary is 0000101. Okay, something like that. Then you're going to want to take the ones complement of that number. Okay, and so in order to do that in binary, there is a trick, and you can simply swap the ones with the zeros. It's pretty simple like that. You just swap, all the zeros become ones, all the ones become zeros, as is illustrated here. And then the last step is to add 1. So that's the 2's complement. You just add 1 to whatever number you just had, and boom, you're done. So that -5 originally looked like this. Then this is the 1's complement. Finally, here's the 2's complement. This is -5. Wonderful. So now let's talk about -2 in hex. It's a little bit more complicated, but this is going to work every time. The first thing has not changed. That's step 1. You're just going to write it in positive hex. Okay, so the -2 is just write 2 in positive. Write +2 in hex. Wonderful. So now for step 2, when you take the 2's complement, you can no longer switch the 1s and the 0s, okay? Instead, what you have to do is take the number and subtract 15, and then take the absolute value of that result. So for example, you take 2 minus 15, -13. Absolute value, 13. 13 is D. That's why I have a D here. Okay, what about 0? 0 minus 15 is -15. Absolute value, 15. So that's going to be an F. So you put an F here. And that is how you do it. Now, by circumstance, that is actually what we're doing here. So the subtraction, we're not subtracting 15, we're subtracting 1 because this is binary. So the way that works is you say, okay, take the 0, subtract 1, absolute value, -1, and convert it to a 1, and that's how you get zeros turned to 1s. So this process is going to work always. If you need to take the negative of octal, you do -7. If you need to do hex, you do -15. If you need to do decimal, you do, I guess, -9. You just always do 1 minus, whatever the base is. So that's how that works. And then don't forget the last step, of course, you got to add 1. So hex, you just take 2 in hex, then you do the 1's complement of 2 in hex, and then you do the 2's complement of 2 in hex. And then you've got -2 in hex. Wonderful. So you can also think of the most significant bit in a binary number as -1 times 2 to the n, and basically all the other digits are simply adding to that. And then another thing is if they ask you to do some sort of operation with the bits, so for example, they might say, hey, take this hex number and subtract it from another hex number. Well, what you should do is you should just take the hex number that's going to remain positive, keep it how it is, and add it to the 2's complement of the number you need to create negative. It's always easier to add the numbers than to subtract them. Okay, another curiosity is if the hex number starts with 8, 9, A, B, C, D, E, or F, and it's a multiple of 4, then it's always going to be negative. I'm not exactly sure why that is. If you know, let me know in the comments. And the other thing is, with a binary number, if you're in Visual Studio and you see a number that's written 0B and then it's a whole bunch of numbers, that means it's binary. It's writing in the binary expression. Similarly, if you see a number that's written 0x something, then that's the hexadecimal expression. Wonderful. So now let's talk about floating point numbers. So a float, it's going to be 32 bits. And what's going to be in those 32 bits? Well, let's talk about it. The first bit is going to be the sign bit. This is a sentinel. Is it positive? Is it negative? The next 8 bits are going to be the exponent. But it's not just the exponent. It's actually going to be a value, which you'll then do 128 minus that value in order to get the resulting exponent. And the reason why they've done that is to center the numbers, to center the values that a float can take on around 0. We'll talk about that in just a second. But the remaining 23 bits are going to be the significand. So I can never remember that it's 23 here. I simply do a float's 32 bits. I need 1 for the sign, 8 for the exponent, and then I do, okay, what is 32 minus 9? And then hopefully, if I can remember, that is 23. So that's how I figure out how many bits are going to be for the significand, or also known as the mantissa. So curiosity that occurs when you have multiple... Well, when you've got all the things centered at 0, you're going to have less accuracy at far numbers. And so this has been a problem. So, for example, I remember when I was working at Sony Santa Monica, they were talking about this for God of War. A really good programmer, Korai Hagen, he was saying, you know, there's a situation here where you're going to have lesser accuracy on huge levels because there's a bunch of vectors you're working with that are coming from the origin. And so if you're, you know, 1,000 units from the origin, you're going to have much less accuracy than if you're right on top of it. So that's just something to consider when you're doing vector math with really big vectors. If they're floats, which very often they are because doubles are a little too expensive to use in game development, you need to be conscious that how far you are from the origin is going to directly impact your accuracy. Okay, the last thing is hashing. So I really misunderstood hashing when it was first explained to me. I don't know why, but I had it in my mind that it was serialization, which is completely not. It's totally different. And what that means is that it's not actually like doing anything to the data. It's really just interpreting the data in such a way that it can create a number, and that number is really useless beyond the single application of it helps you find an index in an array where the value is stored. So just keep that in mind. A hashing is not serialization. It's really just used for lookup. Hashing is one directional, meaning that you can generate the key, meaning that you can create a value from a given key, but you cannot generate the key from the value. You can't go backwards. This is a big problem, right? So for example, when I was on, again, in the God of War video game, a lot of the strings are, you're just going to see the hash values, and there's no way for you to convert from a hash value to a string. And so in a debugging situation, that can be pretty frustrating. So just keep that in mind. You know, if you're working with hashes, there's no way to get from the hash to the actual value. You're going to have to look it up in whatever the table is. And that concludes the binary, hexadecimal numbers, floating point numbers, and hashing segment of the guide. Join us next for conversations on alignment.